Welcome to Brain Vision.
In this problem, we have an I-beam that's being lifted by a crane. The cables attached to the I-beam make a 70-degree angle with it. The I-beam weighs 8 kilonewtons and it's being lifted at a constant velocity. So what we need to do is isolate the forces that act on the I-beam. So let's draw our I-beam here. And then we have a tension in the left cable and a tension in the right cable. We'll call this T1 and T2. Now, we also have the weight acting, and assuming that the beam is uniform, the weight will act at the geometric center, and we'll call that W. And so this angle between the beam and the load is theta, beam and the tension. And so we have components of each of these tensions. We have a component in the Y direction, and we have a component in the X direction. So in the Y direction, because of the angle, this is T2 sine theta, and the other one is T1 sine theta. In the horizontal direction, we have T1 cosine theta, and this one over here is T2 cosine theta. So now we need to summate the forces in each of the vertical and the horizontal direction. So let's do it in the horizontal direction first. So the summation of forces in the X direction, and notice we've called X to the right positive. So that's equals T1 cosine theta minus T2 cosine theta. And because the acceleration is 0, that is all equal to 0. Canceling out the cosine theta, we find that T1 must equal T2, and let's just call that T. So in the vertical direction, again, up is positive, so we have T1 sine theta plus T2 sine theta minus W, and again, since it's being lifted at a constant velocity, the acceleration is 0. Now we can get rid of the indices on our tension because we know that they are the same. So we solve this for T, and we find that T equals W divided by 2 sine theta. Plugging in the numbers, we have 8 kilonewtons over 2 sine of 70 degrees, and that is equal to 4.26 kilonewtons. If we look at our answer that I've boxed here in symbolic form, we can see that as expected, the tension increases as the weight increases. And I'll let you think about how the tension varies as the angle theta changes.